Okay, we're going to get started with DevOps Bootcamp, lesson number 11, a bit about the history of DevOps and an intro to configuration management. So, as I just said, we're going to talk about DevOps, about where we used to be and how we've gotten to where we are with this and what we actually mean when we say that word, and then what configuration management is and how this makes your life easier. So, what is DevOps? Hi, Lance. I jinxed you into showing up.
So sorry about that.
That's fine. I was like, okay, I'll give until 20 past, and then I'll just get started. And getting started was jinx it into magically appearing, and lo and behold, it worked.
Sorry about that. I forgot I had to heat with my landlord to replace the dryer before he took off for vacation.
Oh, man.
Okay. So you literally just started?
Yep. Literally just started. There's your first slide that we were just up to.
Oh, wow. Okay. Thank you for staying. And have you talked about the slide yet?
I have not talked about the slide yet.
Okay. So, what is DevOps? Yeah, that's what we're going to talk about a lot today. You could look it up online. It's a big buzzword. But basically, it's a way of combining software developers, ops, and QA all into a cohesive system that works elegantly. Here's a Venn diagram that kind of explains it a little bit better. So you have the software engineering, which is the developers, technology operations, and quality assurance. You kind of need to have all these to make a cohesive product come out the door in a quick way. So that's kind of a good way of representing it. So the old view before DevOps. So it was viewed as the developers side are the makers. All they do is make the code. They don't really need to care about how things happen. They just make the software work. On the ops side, they're the people that deal with, hey, we got this code, now we need to make it go. And oh my God, why do they have this crazy install process and I don't know about? And so they try to deal with the part afterwards. And this siloed environment was really bad over the past 20 years. And it really affected the industry. And it's still going on right now. If you go into any big corporations, such as probably Boeing, I know we've had some students that gone there, and they were terrified by what they saw. So you'll see it. So the whole point of DevOps is burning the silos down. Hopefully you enjoy my little picture of a silo being burned. And when I say silos, I mean like the devs and the system administrators and so forth. So it's kind of a big deal. So the history of it, so kind of how did it come to be? And this kind of ties with later slides I have about configuration management. Towards the middle of the 2000s, we kind of figured out, hey, configuration management's awesome. We can manage all these systems, but we're still having problems. What's really going on? Why can't we make things go better? We need to figure this out. And so through a couple of conferences and interactions with some folks, it kind of started. So in the first Velocity conference in 2008 and in 2009, it kind of had some presentations hinting to this, like, hey, we need to make the devs and the ops work together. How do we do this? And kind of the term of Agile system administration kind of came up at that point. But it still hadn't quite gotten to the point where you can kind of talk about, or they kind of knew what it was. What did it mean? They're just kind of having discussions about it. And then in 2008, at the Agile conference in, I think, the UK, one guy put up Birds of a Feather, which is an ad hoc kind of bar camp like session at the end of a day for a conference. Hey, let's talk about Agile infrastructure. The guy who actually submitted the BOF didn't show up, but another guy did. And so then he kind of realized, like, yeah, I still think this is a big deal. Like, we need to do something about it. And that was actually Patrick DeBow. And so he just started. He had his own self-interest where he was dealing with some corporations in Europe where there was all these silos. They couldn't get anything done. How do we fix this? And so he kind of had talked to some people at Velocity conference and kind of got things going. It's like, hey, let's make a little mini conference out of this. Let's call it DevOps Days and see what happens. So they had their first DevOps Days in 2009 in Ghent, Belgium, and it was a huge success. Yes?
So what do people mean when they call things agile?
I have that on the next slide, or in a couple slides. So that's referring to the type of development model, and I'll kind of talk about that in a little bit. So that's kind of the history. There's actually a great video. I need to probably link it in here of a guy, one of the first guys that kind of was with them at the same time that kind of described the whole thing, how it started. But it was just kind of like, hey, we have all these problems, we need to fix it. So the Agile approach. So what exactly is that? How many of you have heard of Agile development? Okay. So the whole theory behind it is basically do more releases of code, push more code, don't have a very concrete, well, you still follow a set of parameters, but you don't go through the waterfall method, which is you design, you write code, you test it, you deploy it, and then you maintain it. You do the big code push at the very end kind of a thing. With Agile, you get to the point that it's mostly working and you push it out. And then I have this little feature, 2 weeks later, let's go ahead and push it. And so it's very iterative, very incremental. The requirements can change, and they're meant to change. In other methods, it's very strict, like, oh, we'll have to deal with that later. There's also a pretty short feedback loop. Say, hey, like, oh, this feature isn't working. We can fix it. Let's move on. And there's also a really big focus on quality and quality assurance. So making sure that, since we're pushing code so often, we need to make sure we have tests in the code to make things work. So a couple of individuals got together and they created this manifesto that kind of described what was the Agile approach. And so here it kind of talks about it. It says, and at the very bottom it says, the value on the items on the right, while there is value on the items on the right, we value the items on the left more. And it looks like we didn't quite fix this. But so individuals and interactions or processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. And I think that's a really big, that last point is really important. Being agile, being able to quickly, flexibly change. So this is really evident in the development world, not so much in the operation system administration world. In the ops world, it's very much, we want to have a stable system, we need to have things predictable, we don't want to change things a lot, and so forth. So what DevOps really is about is adapting Agile to the ops world. It probably applied more to the system administrators than the developers at the time, but it also goes both ways. So one of the biggest things that kind of came out of it was, thinking about, yeah, we have configuration management, but what does that really mean? So what happened is more tools were created so that we can have infrastructure as a code. So the infrastructure can be described in code. So you can say, I need 1,000 servers that run Apache that act in the same way. Having that in a code form is a lot easier to deal with than manually spinning up 1,000 machines, configuring it by hand, and all of that. So being able to adapt to that was a big deal. Probably the bigger thing is integrating the operations staff with the development staff and the QA staff and kind of put them in the whole product process. And when I say product, it can be a project of any kind. And we've had these same problems in the open source level. We're writing our own software. We're still running into those problems where we write software. It works on my workstation. It works in the development environment. We get to production. Oh, it's different. Why is it different? It shouldn't be different. So DevOps is about getting everything integrated together so that the ops people know exactly what's going on with the app deployment. The dev people know exactly how things should be deployed, how the environment is, what they need to work with. The QA team understands both of those worlds and creates a QA process that fits into it completely. And that kind of gets into the next point of continuous integration. How many of you have heard of continuous integration? Okay. So continuous integration basically means, think of it this way. I push a code. I wrote some code. I push it up to the code repository. And continuous integration, you would have a system that receives this commit, and then it goes and it runs a variety of tests. And then it runs those tests. If it passes, it says, "Yay, this is awesome." you did a good job. And in some cases, it'll automatically merge it into a stable branch. That's how a lot of these bigger operations work. But if it doesn't, it stops and it says, your crap is broken, fix it. It doesn't get into the stable mainline. And it's, they can run their own local tests, but continuous integration can kind of do more long-standing tests. It can do it automated. It can try it on a variety of platforms or situations that you may not have accounted for, and so forth. But for example, a lot of big companies like Facebook, when they push out updates, they don't have like we're going to push this update on this date, this time. It's like, we're going to just push it whenever, and it just goes live, because it should just pass all the tests if we have our test suites correct. And so that really empowers the developers to push the code out when they want to, instead of waiting for ops to get the systems ready to push it. And another way to put it is give your developers a pager and put them on call. And basically what that means is if something goes wrong with that software, they get buzzed in the middle of the night and they have to fix it. Before DevOps, it was the ops person that ran into that problem, and then he didn't quite understand how that software worked. So then what the heck am I supposed to do? Then you have to get to the dev, and then they fix it, and yeah, communication breakdown. Another aspect it is, utilizing a lot more unique type of metrics and monitoring schemes. So we really haven't done that so much at the lab, but a lot of these other places have a very well-tuned monitoring and metric systems, so they know exactly when problems happen. I saw a talk at Monitorama this week where the guys from GitHub said, hey, we had the system that whenever an issue happens, it automatically creates a GitHub issue, and then they have this other graph that checks various things, and they know, hey, this is probably a pattern of DDoS you need to know. Having systems that understand those types of problems is really important. So that's where the developers work with the ops people to understand how the whole system works, and they understand, well, hey, I should probably write my app in a way that I can easily monitor it and know metrics and know when things are going bad and when things are going great, and so forth. So that's kind of an overview of how do we make ops agile. So at the same time, up until the mid-2000s, there was really not a lot of tools to do things in an agile way in ops. We had a couple of configuration management tools, but they had very specific uses and they couldn't adapt. So over the last several years, things have just grown. Some of these I haven't even looked into myself, but there's a lot of release tools. Jenkins, which is an awesome tool. Travis CI, which kind of ties into that. There's a whole bunch of new configuration management systems out there. There's a lot of orchestration dealing with how do I deal with this whole ecosystem of everything and make sure everything talks to each other. A lot more interesting things in the monitoring realm. And then a whole bunch of stuff in containerization and virtualization with cloud and everything. Back in the mid-2000s, it was like Zen. That was it. Now you have all these other options. Like I can't even keep up with Docker, which is the newest, latest crazy stuff. So that has really, really helped this whole movement. I mean, it's empowered the whole movement. I mean, I can't go into what each of these are, but feel free to Google them and learn about them. But the last thing you're probably wondering is, well, isn't that basically no ops? No. The last thing we want to do is to get rid of the system administrators, because they understand the system level related things that they need to do. I'm not saying that the developers can't do that, but you need to have people that are really good at those specific skill sets to work together. So the problem is that the old ops principles and processes and all these practices that we came up with just couldn't keep pace with the new business environment that was happening around us. All these startup companies like Twitter and Etsy and Facebook and all these other companies that have made some amazing tools, that was their competitive edge. They could build out these systems, they can do these amazing things. If you wanted to do a startup company and you couldn't keep up with this, you were screwed. So that's really a big deal. And really, the other problem, kind of going back to the business model, they all kind of need to be interconnected. The business folks need to understand how the dev process works as well. But the main point I wanted to make is that you have the people that have a really deep development skill set, but we also have the very deep ops skill set people together, when you put them together and have them interact and collaborate, awesome. So that's kind of the whole point about DevOps. And the other point is that the ops people need to do a little bit more development work than maybe they were before. I mean, historically they did scripts, Perl scripts, whatever, but really they need to be more involved in, deeply involved in how the packaging, how to deploy the app, how it kind of works. They don't need to write the application, but they need to dive in more into how the application works. And then on the flip side, developers need to have a little bit better understanding of how the operations world works, you know. They can see it from their own viewpoint of, well, it works on my workstation, I can do these awesome things. But sometimes it's hard to relate that to, well, how are you going to make sure it's always going to run? How are you going to make sure 10,000 hits will make it work right? You know, things like that. How are you going to deal with security upgrades? You know, what if the library version is different? How are you going to deal with that? So there's a whole variety of things. So it's pretty cool. So sound, yes.
Sound comes out of? Oh, they took away the sound cable. That's interesting. And my speakers are kind of crummy, so I apologize.
Do I have a cable?
There
No,
used to be one on the podium. Maybe it's in the podium? Podium is locked. I forgot that.
I might check the other room real quick.
Okay.
Anyways, I have a couple of videos that kind of describe it. We're not going to watch this whole video, but the beginning of it, I think, describes this whole process really well, so you can kind of understand it. And then the second video I have is a little funnier take at it. So, so hopefully we can find an audio cable. Okay. Well, we'll just make this work. It's pretty quiet now. You might want to just close the door in case somebody comes through, and we'll just make this work. Is the volume already turned up?
Volume should be on max for speakers.
Does the buttons work?
Those buttons kind of don't work.
Okay, well, let's just start it and see what happens.
Oh, that's the problem. Oh, yeah.
Oh, yeah, that's a good idea.
There we go.
So let me start it all over again. Ah. So is this all the way turned up?
Let me check that it's all the way up. My speakers are not excellent. Yeah, my speakers are very much not excellent.
Okay. Well, that is unfortunate. So go ahead and start it and go to full screen.
Ah, yes, full screen is important. Okay, so YouTube, you lied to me.
I guess we'll just do it this way. Not even one thing.
When Dave's code is finally deployed into the production environment, occasionally unforeseen errors or problems occur. This mostly happens because Dave is focused on writing code for his development environment, and it's not identical to the production environment. Meet Dave's coworker Anna. Anna is a system administrator from the operations. She is responsible for maintaining and ensuring the uptime of the production environment. The number of servers that she needs to administer is constantly growing because her company continues to launch new products and customers are consuming more of their services. This increase of servers has caused some challenges for Anna. The tools that she used to administer a few servers are not as effective when used to administer a much larger volume of servers. This challenge affects how new code is deployed in her production environment. Usually, when new code is released, it takes a little massaging to fit in the production environment. This is why she requires code deployments to be scheduled and are only allowed once measuring application performance. If Anna and Dave's teams were more DevOps oriented, they would do a few things differently. They would place more focus on automation. DevOps teams try to automate everything, from testing of new code to how infrastructure is provisioned. They would write software in small chunks that are integrated, tested, monitored, and deployed, usually in hours, versus the traditional way of writing large chunks of software over months, and then do weeks or months of testing. Plus, they will have identical development and production environments based on the same configuration. Writing small chunks of code will allow them to increase the frequency of deployments and improve the time to deploy new code. It also enables them to adopt an iterative process to monitor, measure, and improve the code and operations every day. Improve their ability to respond to market needs or other things that impact software. Instead of building and configuring software plus infrastructure manually on an ad hoc basis, Anna and Dave's team would write configuration management code that describes how things should be built. As a result, they will have the ability to build infrastructure at scale to dozens, hundreds, or even thousands of servers in multiple locations using different types of hardware. Another change that a DevOps-oriented team would do.
I think that covers the basics of it.
About source control. The developers should be using source control to begin with.
Yeah, so that's a good little video, and it'll be linked at the end if you want to take a look at it, or it'll be on the slides itself. So, any questions so far on this part? Cool. All right, I'm going to show the other video.
Does anyone have better speakers than my laptop does?
I could get one out of my car. I just have to run out and get it. Mine are pretty good.
You know that it's probably worth it for that video because like.
Is yours pretty good?
I don't know.
Do you have slides.oscosl.org and then go to 11 or go to DevOps Bootcamp and then to number 11? We can just patch the videos into the video later.
Yes.
Mine's pretty good.
Yeah.
Oh, yeah.
Pause it.
Chromebook, yeah. Pause. Wow. This Chromebook just like epically succeeded. Shoot. Shall we just try and start them at the same time?
No. We'll just plug this in.
Okay. Assuming the Chromebook has VGA out.
I don't have VGA, only have HDMI.
Oh.
So let's just do this the hackish way.
Yeah, let's do it. We'll do it
Let's set them both side by side and just have the same person launch, so nothing could possibly go wrong.
Well, I was thinking you could sit the speaker.
Oh, well.
Oops. Yeah, the whole nothing could possibly go wrong part. There we go.
One, two, three, go.
This is a closed loop farm.
Close enough.
Closed loop meaning that everything from the pigs to the food are working together towards the 100% self-sufficiency of the farm. Everything on the farm has different roles, but the collective goal is the same. I don't like horses. I'm not a farmer. I'm a software engineer. In our world, the animals have forgotten how to work together towards the common goal. What we need are happy customers. We have a way of doing this. It's called DevOps. Does DevOps work? It works like the farmer on the business end of a sport. It's kind of cute. I think I can sell it on Etsy. Will DevOps make your customers happy? No. I don't like them. Does a farmer milk a chicken? Or try to get an egg from a cow? I don't know. But in DevOps, we celebrate each individual's contributions. The output from one part of the system feeds the next part of the system, which helps the next part of the system thrive. This poo fertilizes the hay that the cows eat. Henry, you eat poo? It's gross. Happens. Does DevOps mean there won't be any bugs in your system? Of course not. But you'll be better equipped to deal with those bugs. DevOps means you trust and empathize with your teammates. But you cannot DevOps alone. In DevOps, who are working together with your community, stirring up the light. DevOps requires sharing your data with your team. What do you think of that data, Henry? Henry? Should you tear down the silos in your organization? No. You should blow those suckers up. Stop waiting for someone else to transform your business. Let's go change the world. Together.
So yeah, that's a rather amusing way of looking at it. So yeah, any questions? They have a slightly less safe for work version that has the curse words included in it, if you want to check it out. But I thought I would be professional and not show that version. So anyway, so that was DevOps, and now we're going to kind of go into a brief introduction of configuration management. So what it is it's a way to basically manage all your systems, all the physical systems, their configurations, a way of doing all the things. But before we get to that, let's kind of get to a history of how configuration management came to be, and I shortened it to CM in case you hadn't figured that out. So in the mid-1990s, back in the dark ages, probably when you guys maybe were born, there were very, very few systems out there, especially Unix systems. So there was only a couple around. You didn't have that many you had to worry about. And so the term unique snowflake system was kind of the term. So you would create the system. You would manually configure things. You know, it would be a very unique thing. It's a pet, as we like to call it. And so that's just how things were. You know, it worked. But then in the early 2000s, you know, the x86 commodity hardware came to be, Linux became more popular, and so we have more Unix-like systems that came about, and that problem quickly needed to be solved. And about the same time in the mid-1990s, and I can't believe I actually didn't put his name up there, Mark Burgess, he did actually some research on configuration management. He's from the University of Oslo, I think, in Norway. And so he created a program called CF Engine. It was first released in 1993, so it's a fairly old project out there. But the big thing is when he released version 2 in 2002, that's actually kind of when I got involved in it. It was a huge deal. It did amazing things for people. And people were just starting to learn about configuration management. So CF Engine was like the granddaddy of all configuration management systems that were really, any of them you really want to care about. And then as we progressed through the 2000s, you know, CF Engine did a great job, but there became this need for more agile ways of managing systems. And CF Engine just couldn't fit that bill for very well. And so other configuration management systems kind of were born out of that need, out of that time. So, and you know, the cloud started happening towards the mid-2000s, later 2000s as well. And things like CF Engine just did not fit that really well. And so things kind of had to change. You know, in around 2008, we kind of felt that we got it down that we know how to provision and manage an individual system really, really, really well. But when we're dealing with multiple machines, hundreds, thousands, tens of thousands of machines, if you're doing a lot of agile-related crazy setups, you know, we hadn't quite figured that out really well. And we're still trying to figure that out. Yes?
So what is provisioning a system?
Provisioning a system, meaning installing the base operating system and then configuring it in a way that you want to run whatever service you want to run on. So if it's a database server, installs it, gets it set up, does that all for you. That's kind of what I'm talking about provisioning. So what really happened is that configuration management needed to turn in the code. And so essentially that's what it is. In configuration management, we define what our systems do in a code format. So you can say, this system here has this installed set up this way. This system here has this set up in this way, and so forth. So it does things like install packages, it configures the software, it might start install services. I mean, it can do anything you can think of, basically. It also ensures that the state of the machine is in a very specific state. One of the unique things about CF Engine was they used this promise theory and convergence. So basically it meant that we should be able to run CF Engine multiple times and get the system to converge to a same state. And that's really important. You know, if random user comes on the system and says, oh, I want to edit this file because it needs to fix it, you want your configuration management to fix it because that's not what it's supposed to be. You know, the system will come here and is like, this file is not what it's supposed to be, so I'm going to override it to what it's supposed to be. Another thing about configuration management is that it really ensures the policies that you maybe have set at your institution, group, or whatever, and standards are in place. So we want SSH configured this way. We want to have the firewall set this way. We want to have these nice tools installed this way. We like HTOP because top sucks. You know, stuff like that. You know, you would just have in your configuration management. And whenever you deploy or provision a new machine, the configuration management thing does it for you. The other thing is that typically configuration management is housed in source control. So you can provide the history of like, well, who made a change, when, what. You know, we've had this happen before where we're like, well, this problem started happening 7 days ago. Let's look through the CF Engine repository and see what changes we made on that day. And then we can kind of track down what happened. And it also gives you the ability to revert a change, in theory, depending on what you're doing. So that's really, really powerful, especially if you have lots of systems that you don't remember why you had it set up a certain way. There's been multiple times where I've put a message to my future self into our configuration management Git repo because I know I'm going to forget why I did something a certain way. And I'm going to find the Git history of the file and be like, oh, that's right. That's what happened, and I have to do it this silly way. The other thing is that you can rebuild the system really easily, really quickly. You know, that whole mantra in the late 90s and early 2000s, if you have these pet systems, you know, well, we can't change it because it's set up in a weird way, and it's not all in configuration management. You know, you want to be able to redo it quickly. I mean, in the mindset of the cloud, that's really important. You know, because now you basically can blow systems away at willy-nilly. You can deploy new ones, and you want to have a system that can get things going really quickly. And you really want to be able to orchestrate everything together. You're like a conductor, essentially, when you're dealing with configuration management. You want to make sure everything kind of works together. So I'm going to kind of go over a couple of platforms. I'm not going to cover them, every single platform out there, but I'm going to cover 4 that I think are kind of the big ones or the big-ish out there. So I want to start with the granddaddy of them all, the first one that ever came out with CF Engine. It's a really lightweight agent system. It can manage tens to thousands of machines without much effort. It scales extremely well. It can run in a client-server environment, or it can run in standalone. It has its own domain-specific language, which can be a pain in the rear sometimes. But hey, there it works. Puppet essentially came out of some frustrations with some folks using CF Engine, especially with the developer CF Engine at the time. And we all know how open source software works. He decided to create his own system, and so he created one called Puppet, because we all want to be puppet masters and manage systems. So Puppet created its own declarative language as well, so you can describe its configuration. It also uses a client-server model as well. So it's set up very similar to how CF Engine was, but in a slightly different way. And it was powered by Ruby in the back end, while CF Engine is actually written in C. So there's that. Now we move on to Chef. Chef actually, ironically, came out of some folks that were using Puppet that were frustrated with how Puppet worked. And I'll talk about some of those issues in a little bit. And they decided, well, this sucks. We want to be able to do something different. So let's create something called Chef, and we'll go with it. And the main thing that's different about Chef is that the actual code that you use to define your systems is using pure Ruby. It's not some domain-specific language. It's Ruby. And this also uses a client-server model. Yeah.
What do you mean by domain language?
I will talk about that actually in the next couple slides. But basically, it is. So Puppet has a language that's very specific to itself. It's not like C, it's not like JavaScript. It's very much, it looks like JSON, but it's not quite like JSON. So they describe how it works. That's what I mean. Is there a better way to explain it?
I would describe a domain-specific language as if you've got one particular little problem to solve, and there are ways in which a larger language doesn't really solve it as well as it could be. then you can actually implement one language in another. This is basically how compilers work.
Yeah.
And so you invent just an incredibly simple little language that solves this particular problem, and the benefits of having a language perfectly matched to the problem outweigh the drawbacks of having to learn how it's different from the languages in.
You'll see it here in an example, and I can kind of show it in a little bit. And another one that's kind of been fairly new, I think Ansible's only been out, I think, for 2 years now, is Ansible. So it's basically SSH in a for loop, but with fancy stuff. So you can do multi-mode deployment. You basically write scripts to describe what you're doing, and it just uses SSH. I mean, there's really no agents. So it has the simplicity factor, but then you lose control of doing things in a more complex way.
So Ansible is basically just automating yourself if you were to go do it all by hand.
More or less. It's a little bit more than that.
Yeah, I've been using it for a while. Kind of like that. I mean, the reason I even started using it is because everywhere I look, people said it's the easiest to pick up, and where I work.
Compared to Puppet and CF Engine, it is stupid easy.
Yeah.
and Chef.
Yeah, like I even created some packages just to set up my workstation.
It's,
not even.
Yeah. And in our point of view, it's basically like Chef, but with Bash. So you basically write everything in Bash, and then you configure it, I think, in a YAML file, and then you do your dependencies that way, and that's kind of what happens. So I'm going to do a very simple example with Puppet and Chef, just to kind of give an example. So this is installing Apache and starting the service, making sure it's installed and started. So this is where I'm talking about the domain-specific language. This does not look like any other language you know, probably. It looks probably similar-ish to JSON, maybe a little bit of Ruby, but they define it inside of their environment. So here it's saying, I'm defining a package type. I'm going to call it Apache, but since I'm on CentOS, the package is actually called HTTPD, how things are. And I want to ensure that it's present, so install it. And then here I'm saying, I'm going to make a service called Apache. It's actually called Apache. I want to make sure that it's actually running, so start it. Make sure that it starts on boot, so when I reboot the machine, it starts. But before I do any of this, I need to depend on this resource, which is a package recipe. So this basically says, I have a dependency that needs to happen before this happens. Does that kind of make sense? Any questions? It gets much more complicated after that, but this is a very, very basic example. Oh, hey, Ben. Hi. So now we'll get to a Chef example. Doing the exact same thing, although I don't think I put in the dependency. I think I realized that. So I'll have to fix the slide later. But here I'm defining the package. I'm going to say I actually need to install this package. I'm installing it. I have a service, and I want to enable, and I want to make sure it's started. So this is actually Ruby. This is Ruby code. There's one line I probably need to add in there to do the dependency, or I need to... Actually, no, there is no dependency. That's right, because this is Chef. So Chef doesn't have dependencies. You do things in the order it happens. So when it executes this code, it's going to do this, and then it's going to do this. So that's kind of its way of doing dependencies. And that's really one of the biggest differences between Puppet and Chef. Any questions about this code? One nice thing about this is that you can do for loops, but you can't do that in Puppet, because Puppet is a domain-specific language, a DSL. So you get frustrated sometimes when you want to do that. So let's kind of compare all the platforms. Well, CF Engine, it scales crazy well. You can really, I mean, Google and a bunch of other people have used it for many, many years, although they use other tools too. The problem is it doesn't really fit the Agile method very well because of some of the issues. Now, they have a new version, version 3, that I personally haven't had much experience with, but I think it has fixed some of the problems that version 2 had, but it completely broke any previous scripts you had or configuration that you had defined. So you have to rewrite it to make it work with CF Engine 3. With Puppet, its main mantra is that everything is a dependency tree. So I have the service, but before I start the service, you have to install this, which is great. You think it's great, but when you start getting into complex systems, you might need to have something very specifically do something first, but depending on how the dependency tree is resolved, it may not happen the way you think you want it to. And so that's where a lot of the frustration came out of the original authors of Chef, where, hey, the dependency tree thing is crazy. I mean, it's great at certain tasks, but if I'm trying to do something very specific, it doesn't work very well. So that's one of the biggest problems. And also the DSL can be problematic sometimes. There's a lot of times like, man, it would be so easy if I just could do it on a for loop. I want to iterate through something. And they fixed a lot of this. They have added other features to kind of mimic some of this stuff. So they're kind of figuring out ways of fixing that. I'm not saying that Chef is amazing too, because it has its own set of problems. But the way Chef works is it executes commands as you see them. So you know it's predictable, you know what it is, but then you run into the problem of, well, if you don't do this the right way, then things might not work right. So you have to be really careful how you execute it. And being able to use a full language like Ruby offers a lot of advantages. But then it's also disadvantages. In the case of the lab, at least for me personally, I don't have much experience with Ruby itself. I can understand the public DSL because it's simple, and that's kind of why they did the DSL in the first place. They had the idea that system administrators don't need to know a full language. Most of them knew Perl, maybe, but now I need to know Ruby. And for me, I can pick it up and make it work, but that's kind of like a roadblock in some cases. And each of these platforms has its own level of complexities and issues. So, I mean, we've run into that ourselves. We used CF Engine for quite a long time, and then we tried to run in Puppet, and we ran into some issues. Now we're working on Chef, and then we're running on our own issues with that. And so it's like you can never find a platform that does exactly what you want. We could try to go with Ansible, but then we'll probably run into something completely different too. So that's kind of what's going on with that. So that's basically my talk. I have all of these links up here for the content that I had. Be sure to kind of check it out. I'll try to add a couple of more links as well. But now we're going to kind of do an interactive thing, because this is not something we kind of can do hands-on. So I was like, well, we'll do a scenario. Yeah, we'll do an example scenario of like some things and have you kind of interact with it.
So first off, we have the traditional workflow, which had a blurb on there. Basically, we have a couple of people. We have Mary Smith, who is a developer. She's trying to deploy our System View app on their infrastructure because it's their flagship product of their company, right? So they've got this deadline that they need to meet. And we have Ivan Boff, who is the systems administrator. His job is to make sure that nothing goes down and that nothing has security vulnerabilities. So we're going to see kind of how this plays out. And so pay attention as we go through their email conversation and see what you notice about how they're communicating and how their work is getting done or not getting done, as the case may be. So Mary starts us off with Ops team, as discussed in the release schedule distributed by our boss on such a date. The development team's ready to deploy our flagship product, System View, this week. We'll need Python 3.4 and a virtual end on the production server, as well as correctly configured Nginx vhosts to direct the users to our site. When we log into the production server to deploy the app's code, we'll need permission to write to var DOB and all of etc for configuration reasons. Please also create the user and tables detailed in the attached spreadsheet in our database. So, do you know what happens when you make a lot of requests in one email? So, sysadmin writes back the next day because he was busy. He was putting out some fires in the data center. Our production systems are standardized on CentOS 6, so Python is only supported up to version 2.6. The Python 2.6 version of virtualenv can be installed after you work with legal to file documentation of a full security audit of the package. He's like, you're not putting this random code on my servers that I've never seen before, because this will let bad people in. So providing any account, let alone route to developers on a production system, is absolutely out of the question. Just document the app's deployment process clearly and we'll handle it. He's like, okay, I let somebody in to run this server. They break it, I'm on the hook. Not going to happen. So sounds like it'll be simpler to just install the dependencies directly on the server instead of using virtualenv. I should be able to include this in the Jenkins configuration as long as the continuous integration user is running as root. Speaking of which, the development team will need access to Jenkins or other continuous integration in order to automatically update the site when changes are pushed. Is MySQL dev installed yet? Also, please confirm that the database is at such and such a location. And then So he answers her first question. Why do you need Jenkins? I Googled it, and it looks like a non-standard and immature implementation of some of CF Engine's features. Just give me the CF Engine config, because that's what we're using. The updates will be done with a subversion post-commit hook. So this is something I know. This is something that will work in our infrastructure. Due to administrative reasons, no dev libraries may be installed on production servers. Servers are for serving, not compiling. So do you at least have the Nginx vhost and uWSGI installation ready? She's like, what can I do here? He's like, we don't use Nginx or uWSGI. The spec should have said to convert the app to work with Apache and ModWSGI for production deployment. What's the URL for the database? You will have to contact our database admin and file a ticket to get database access. Oh, by the way, she's on vacation and won't be back for 2 weeks. So this is a perfectly plausible scenario for a standard siloed infrastructure. Everybody's in their own little territory and making sure that they keep it, and mainly concerned with their own performance, and they kind of end up fighting each other a bit. Versus DevOps. So this is less likely to be an email chain, more likely to just be on IRC in some channel. So we have Simon Johnson and Ada OpDev, who Simon Johnson's a DevOps-focused developer, and Ada OpDev is a DevOps-focused sysadmin. So he says, hey, the system view tests are passing on Python 3.4. She's like, hey, I'll spin up a VM on the cluster with the production cookbook. That'll be at such and such a location. Actually, we're migrating to a test cluster. Use this URL. Sure. It's set up for SSH with your LDAP account. So there, he already has access to a dev machine because they have everything automated via LDAP and via the virtualization. And then a bit later, he comes over with the problem. I've been building MySQL Python with the MySQL dev libraries, but it doesn't look like you have those. And what database should I connect to? So this is where our previous friends got completely blocked for up to 2 weeks because their DBA was on vacation. He says, get me a list of the names and databases you'll need, and I'll stick them into our cookbooks to be automatically created. And then she says, I looked at your ORM docs, and you're not actually using any features that changed between MySQL 5.5, which is what we've got, and 5.7. And then he runs the tests with MySQL 5.5 and finds out that she was right. Things will work, which wouldn't happen if your sysadmin was unwilling to read any code. And then he's like, oh, I need root on the VM so I can install some stuff. And she says, no, we're doing that through Chef. Have you written cookbooks? And so she helps him out with some pointers to where he can learn how to write cookbooks. So, and then finally they run into yet another problem. Have we got Jenkins? And so they go through, I've heard of Jenkins but not worked with it, and then they discuss what it'll do and talk about how to get it and figure out a conclusion collaboratively rather than just shutting each other down. So these are kind of idealized scenarios. As you can guess, it's not always going to work this beautifully, but this kind of shows you the difference between siloing everybody's responsibility versus acting like you're on the same team. It can get stuff done a whole lot faster, and it can make everything easier, and you can basically script yourself out of the boring and unpleasant jobs by using the right tools. So questions, comments, observations?
The first change sounded almost kind of hostile. It was kind of funny.
Mm-hmm.
Yeah, that was pretty typical, especially in the mid-2000s.
People just like not working together on it.
Well, it goes back to the system administrator feeling like he's God. He has control. He has power over you, and that's where he has the ego trip with it.
No, like this is what we're talking about with silos. Like if the dev team is one group of the company with their own boss, and the ops team is some other group of the company with their own boss, and something goes wrong, then people are, and let's say you get this downtime and you lose in millions of dollars of revenue because there was this downtime. Somebody's going to go, okay, whose fault was that? And everyone wants to really have their back covered and be able to say, nope, it wasn't our fault, it's their fault. They violated the specs, or whatever.
Yeah, and I was going to say, I mean, that's a worst case scenario.
Yeah, they're exaggerated.
It's rather exaggerated, but there are definitely places where you know, the system administrator may come off as being a dick, but he's just being blunt.
Mm-hmm.
You know, this case he was being a dick, but you know, a lot of times it's like, well, this is how we have it set up. I don't want to do this one-off thing. You should have worked with me to figure this out.
Mm-hmm.
You know, and that's basically what this is all about.
It's kind of how you identify your goals. Like with silos, the sysadmin's goal is to keep the servers up at all costs, and dev's goal is to push their features at all costs. Whereas DevOps, everybody's goal is to have the features running on a working server.
Yeah, yeah. So something else I kind of want to mention is some places like GitHub, they use a lot of features called chat ops. So they have a couple of IRC. Oh, it's not actually IRC. I think it uses a different protocol. Do you remember what it is, Ben?
I thought it was just IRC.
I'm pretty sure GitHub's IRC.
Okay, I thought it was something else. But anyways, they have all of the tools and everything integrated into this IRC bot, and they basically can deploy things from IRC from command line. I mean, they can issue tickets, they can build things, they can do all these awesome things, or they can get feedback from the bot and so forth. So there's a lot of interesting, cool stuff that kind of come out of that. And that's one of those scenarios where the devs are like, we can write a tool to make it connect to this, and we can make it work. And the ops team's like, that's awesome, do it. You know? So.
And it's kind of another case of the automate yourself out of a job mentality, where it's like, I hate having to like manually go out here and click these same buttons every time to deploy. I could make a bot do that when I say bang deploy such and such a host name.
And in reality, you know, there's a lot of companies, I mean, most of the new startups are using the DevOps model, but a lot of the older companies, even Oregon State itself, they're still just trying to get a grasp on it. There's a lot of political, you know, things going on, or like, well, I've never heard of this, we've always done it this way, this is what you need to do, you know. Just be aware, like, that's out there. So, and that's kind of why I realized we finally got to the DevOps talk towards the end of this term, but I wanted to make sure we covered it so you can kind of get an idea. This is really important. Hopefully in a couple weeks, we're going to have some folks from the industry that actually do a lot of DevOps come down. We're going to probably do it during an afternoon during the week. Hopefully you guys can make it. Hopefully we can get it recorded. But it'll be from a company called Rentrack, which is based up in Portland. They do, I can't remember actually what they do. I think they do processing of TV data or something.
Oh yeah, they're the ones that they do big data basically on who watches what TV to figure out like advertising, targeting, and ratings and all that.
Yeah, so they do a lot of Perl coding and stuff, but they've implemented a lot of DevOps methodologies. And so it'll be a great experience for you guys to kind of see, you know, what that environment is like. I'm also going to encourage all the OSLers that have actually been around to kind of get an idea of like, well, that's how they do DevOps. And that's kind of what's going on. You can kind of, you know, we're just starting to get into it. So actually talking to somebody who actually does it on a daily basis is awesome. So we'll send out an email once we figure that out.
Okay. Any other questions, or are we about done with the live stream? Any questions on IRC from persons on the live stream? I'll take that as a no.